Hi, everybody. My name is Sexton. I'm Director of Software Engineering at a company called Lumere. We're a healthcare technology startup here in Chicago. You might know us by our previous name, Procure Health. We've rebranded since the past year. Or maybe you've come to some of the chipping meetings we've hosted down in the vault over there at 33 North of Sun. I'm going to talk to you about doctors' devices, drugs, and Django. So, it's a packed agenda. I've got a lot of stuff to talk about, so I'm jumping right through. Basically, we make software to help hospitals save money, and we do that by finding them ways to cut their costs and by improving the outcomes they have from the procedures they do. This is a big deal for hospitals because they used to be able to rely on regular Medicare increases and everything, but since healthcare reform, that's no longer a thing, and now hospitals are like scrambling to find ways to save money. And one of the ways they do that is by compensation for hospitals isn't based on just the number of procedures they do anymore, it's based on quality of outcomes. So if a hospital treats someone and the process is great and they don't need to come back for follow-up treatments and everything, hospitals make more money if they do that. So finding devices that that are better for hospitals is a big priority. So they have two needs. They have the doctors who want to request medical devices and medications for use at their hospitals. So there's some hip replacement part or some other drug that they want to use for some procedure. And a lot of times hospitals are using paper forms or something that our web application will then replace, so it's all online. That is then tied in. We have a team of medical researchers in-house, and they're all like biomedical engineers and that sort of thing, and they spend their whole day gathering all this data from the FDA, from clinical trial results, filing information, recall information, and they build these device profiles for, ideally, what we're headed to is every medical device that's for sale in the US. And when a doctor submits a request through our application, it'll show up on the supply chain administrator's screen with all the information right there. They don't have to look it up themselves. They don't have to rely on the biased device vendor to give that information to them. So it saves them a lot of time. All the information is right there. And because we're building this huge database, we are linking clinically equivalent products together. So a doctor may request one device, and maybe the hospital has a relationship with that vendor, but they don't realize that the market's really commoditized now around that device. So here are some equivalent devices that you should also consider, and here's all the information about them as well. So they get all this information. They get to see, how is this modeling tools to say how will choosing one device over another affect my finances. They can upload their financial information and stuff. They can record whether or not they approved a device, whether they denied a device, which facilities within the organization stuff is approved for use at, and then also track compliance with those decisions to see is the doctor still using stuff that we told them not to buy anymore, and if we did switch, how is our price looking? Are we actually saving the money you think we were going to save? And we use Python to do all that. Our web application, we really like Python because it's great for web apps. There's lots of useful libraries, and it's all built on Django for us. And we're using Vue.js on the front end, and back end, Postgres, and all that stuff was enabled. Django's very adaptable. You can do all kinds of stuff with it. We've done a lot of stuff with it, and a lot of other people have mentioned that the open source contributions. We do a lot of stuff too, trying to get back to that. We contributed a bunch of the stuff around schema migrations and the ORM. We contributed that back to the Django project. That's been really fun.
Yeah.
But just using the ORM too has been really great. Like we started out using MySQL, and it's enabled us to, with an automated test suite in the ORM, we could switch over to Postgres, run all our tests, and not have to worry about what's busted under here, because we can just swap out the library on the back end, update some places where we're using custom SQL, and it's good to go. So that was pretty cool. We also, for the finance side, we take all of our clients' purchase order data. So the stuff that they're buying, we want to be able to say, you got 3 facilities in your hospital system that are using one device, 2 other facilities are using this different device, but they're clinically equivalent. So if you have an opportunity for savings, if you standardize across all one of them, or we notice that you're paying this price for this kind of device, and other hospitals in your region of your size are paying a much lower price, you can take this data and go back to your vendor and negotiate a much more reasonable price. And we are using pandas and NumPy, and we have some machine learning algorithms that are taking this stuff, and it's all like someone at the hospital is typing this stuff into their system. So if the hospital is ordering a device from like Boston Scientific or something, people aren't just typing in Boston Scientific like you would hope. They're typing in Boss Sci, or including the space or not including the space, or spelling it wrong, or putting in a completely different manufacturer than what it actually is. So our machine learning algorithms are parsing all this data across all the hospitals we take it from and trying to map that purchase order line to the specific product in our database so that we can link then all the financial information and all the research the FDA has. It's cool. We like doing that. It's one of the things I also want to mention why we went with Python to begin with as a startup, because we could have chosen anything. But it's there's people who know Python, which is good. People learn it in school, and it's very clear. Like, you can look at someone's Python code and pretty much understand what it's doing. Like, I programmed in Perl for 10 years, and that is not something that happens in all languages. No one can look at Perl code and know what it's doing right away. So I really like Python because of that. So yeah, it's pretty much everything. We're hiring, so if you go to Lumere.com, click on careers, and you can help us make healthcare better.
Questions? Ooh, we reached the night where people. Oh,
Mostly are all of the APIs REST APIs?
Yes. Yeah, we use Django REST framework, and everything gets requested through that.
One more question. Anybody? Over there?
So basically, you're doing spell check at the beginning when someone is right. Is that
Pretty much. I mean,
And so how do you do that? Is that off your previous? Is it off building?
yeah. I don't quite. Our algorithm for mapping the PO data to our products is called Smart QA. We're checking the quality of the data inputs we're getting. And I don't exactly know how it works because I'm not on the data team. I just know that they have a GitHub repo. It's full of Python code, so I added it to the slides. But it's in general, that's what
Is it open source?
this is not. But
the spell check is not open source.
well, it's not just like spell check. We're doing because there's item numbers, there's catalog numbers, there's different vendor models, the SKUs.
It's all hooked
So
up to your DB.
yeah, so there's a whole bunch of stuff, and we try to map that and train it based on like all these different aliases for different things, and how does one client send it their data? Is there like some prefix that they're always using for different stuff, and we have to strip all that stuff out and do all this kind of thing. It's kind
Perfect.
of messy.
One last round of applause.